that problem here. So yesterday we had to find the area of regular polygons. Didn't have it quite as organized as some of us might need to see it. Okay, so really on the front part of this page, this just has kind of like a word bank for you. Okay, so anytime we need to find the area of a regular polygon, there's a couple of things that we need to know. The first thing we need to know is the angle between A and R. Okay, so A is the apothem and R is the radius. And any time we need to find that angle, no matter the shape, it could be a hexagon, a pentagon, a heptagon, whatever, we always do 360 divided by 2n. Okay, so if you look at the bottom here, it says that n is the number of sides. Okay, so here, this is a hexagon, it has 6 sides. We would do 360 divided by 2 times 6. Okay, so that's one thing that we have to know. We also need to know the apothem whenever we're finding the area of a regular polygon. Now, sometimes you might get lucky and you can use your 30-60-90 rules or your 45-45 to find the apothem. Sometimes you might have to use trigonometry, which is what we're going to add today. And then the other things we need to know are the half of the side, which really that just helps us find the apothem, or vice versa. And then we also need to know the side. And the reason we need to know the side is because if you look at your formulas here, the area is half perimeter times apothem, where the perimeter is the number of sides times the length of the side. Okay, so this is kind of just everything you need to know. There is one thing on this sheet that you don't always need to know, and I should have wrote this, but the radius is only useful in some cases, okay? So that might be useful in cases where we don't know the apothem or the side, okay? So we don't always have to know the radius, but sometimes it can be useful. So if we look at the back part of this page, okay, we're going to make one big example that you guys can have this in front of you to help you as we add some more stuff today. Okay, so if we look at the front side, the first thing we need to go ahead and fill out is the angle between A and R. Okay, that's usually the easiest thing to find because all we have to know is the number of sides. That's all we have to know to find that angle. So this angle here is always going to be 360 degrees divided by 2 times the number of sides. How many sides are in a hexagon? 6, right? So 2 times 6 is 360 divided by 12 is 30 degrees. Okay, so that's one thing we need to know. Now, above, it's given us that the radius is 8. Okay, so the radius is 8. So this is one of those cases where the radius is important because it's going to help us find the apothem and the side. So if we have a 30, 60, 90 triangle, okay, remember this is a 90-degree angle. The apothem and the midpoint of the side make a 90-degree angle. Then how can I find the base here of my triangle? What do we think? It's going to be 4, okay? Because remember, it comes straight from the 30, 60, 90 rules, where the hypotenuse is 2x and the base is x. What is going to be the long leg here in my triangle? Okay, it's actually right here. 4 radical 3, right? 4 radical 3. Okay. So now we've filled in almost everything here. What would the entire side be of this hexagon? 8. Right? Because that base of the triangle down here is half of the side. Okay? So if that's 4, then this is 8. So from here, now that we have our shape filled in, we can now use our formula. So remember, any regular polygon is area equals half perimeter apothem. What's going to be my perimeter here? 48, because we have 6 sides in a hexagon, and each side is 8 units. So my perimeter is 48. And my apothem, we already stated above, was 4 radical 3. So I'm going to take my P and my A and plug these right into my formula. So I have half times 48 times 4 radical 3. Okay, these are my, don't you think they're decimals? Now, remember, as we work through these problems, we're going to get exact answers. So we are not going to multiply by this radical 3. So what I'm going to do here is just 0.5 times 48 times 4. Okay, this is just one way we could type it in the calculator. So 96 radical 3 units squared. Okay, some of us might not as easily see that. So remember, we can always write these over 1. So I would do 48 times 4 on the top and then divided by 2. So I still get the same answer. Okay, so whatever works for simplifying best for you. All right, so I want you to keep this problem out today because I do think this is a little more organized than what our notes were yesterday. So this I want you to keep out to help you if you need it. And then we are going to learn one more part here today, which is really just an extension, okay, because we're going to be doing the same thing in our 10.5 notes. It's just that now we're going to have to start using trigonometry, and you'll see why once we get started. Okay, so take a second and get your Unit 10 notes. So just a reminder at the top that our trigonometry rules, and I like it better as SOHCAHTOA. Okay, well, if we ever need a missing angle A and we want to use sine, then it's opposite over hypotenuse. Cosine is the adjacent divided by the hypotenuse. And tangent is the opposite divided by the adjacent. Okay? So another thing to remember is that the area of any regular polygon is half perimeter apothem. So we're only going to do the first 2 examples here together. So in the first example, we have the area of a regular nonagon with 10 centimeter sides. Okay, so how many sides does a nonagon have? 9, right? So that's important. And then each side is 10 centimeters. So all of the sides are equal and they're 10. So as we work today, I did not mean to put this. So we're going to give exact answers. My apologies. Okay, we're going to give exact answers. Start. Okay, and if we need to use our diagram, okay, we are going to, if I can find it, where should we start here? What do you guys think? here in the middle. Like the apothem and the radius, right? So essentially what we're trying to do is fill in these boxes. But again, the radius is not always needed. Okay, so first I'm going to start by drawing a triangle. So I have to just kind of estimate the center. So there's my apothem. There's my radius. So if each side is 10, remember that the base of our triangle is always half the side. So what would the base of this triangle be? 9. Okay. Now, you have to remember, we cannot use our 30, 60, 90, or 45, 45 rules until we know the angle. Okay, so after I find the side, I'm going to find my angle. So remember, anytime in a regular polygon we're looking for the missing angle here, we're doing 360 divided by 2n. Okay, so I have 360 divided by 2 times 9, because remember we said a nonagon has 9 sides. So what is 360 divided by 2 times 9? 22, or just 20? Just 20. Okay, so that angle here is 20 degrees. Okay, that was equal to 20, sorry. Okay, either way, so as we know. Okay, so now I want to find the apothem. Okay, that's really the last thing I'm missing here, because again, we don't always need the radius. So now I'm going to find my apothem. So I have, now, can I use the 30, 60, 90, or 45 here? No, because it's a 20-degree angle. So I'm going to use one of my trig functions. So if 20 is the angle, and I have a side of 5, and then I have the adjacent, which trig function would I use? Do you remember? This angle here is 20, and I have the adjacent side as my apothem, and 5 is the opposite. Tangent, there we go. So I'm going to use the tangent of 20 degrees equals the opposite side, which is 5, divided by the apothem or the adjacent. Okay, just a coincidence that they're both A's here. Alrighty, so in order to get the apothem by itself, I would have the apothem is equal to, so I'm multiplying both sides by A, but I still don't have A by itself, so that means I'm going to divide by the tangent of 20 on both sides. I have the apothem is equal to 5 divided by the tan of 20. I'm actually going to leave it just like that. Okay, that is going to be the answer that we give here. Okay, we're not going to type it in our calculator. All right, and we need one more thing before we can use the formula. And what is that? The perimeter, right? So we're going to find the perimeter. How do we find perimeter? Okay, again, if we need to look here, the perimeter is the number of sides times the length of the side. So we said a nonagon has 9 sides, and each side is 10 centimeters. So my perimeter is 90. And now that we know the A, we know the apothem, We know P, the perimeter. We're going to plug these right into the formula. Okay, so I have area equals half times the perimeter times the apothem. So right now it looks a little funky. Okay. So remember when we multiply fractions, we multiply straight across, and any whole number can be written over 1. So if it helps us, we can do that. So now I see on the top I have 90 times 5, which is 450. And on the bottom, I just have 2 times 1, which is 2, times the tangent of 20. So 2 tangent of 20. And now I'm going to simplify just one more thing. Okay, because I have 450 divided by 2, which is what? Anything have that? 225? So my answer here is going to be area equals 225 divided by the tangent of 20 degrees. And what would be my units here? We were in what? Centimeters. So centimeters squared. Okay, any questions or comments here on example 1? Okay, so this is going to be the last one that we do together. And then we'll have plenty of time for practice today, okay? So, what is the area of a regular pentagon with 4-inch sides? Okay, so again, we've been given that each side here is 4. Start. What'd you say, Seika? The center, right? Good job. Okay, we're going to start in the center and draw our apothem and our radius. Okay, if the side is 4, then what would the base of our triangle here be? 2. Okay, it's always half of the side. Half angle here. Over 2, how many sides in a pentagon? Good job. So I have 360 divided by 10 is 36 degrees. Okay, that is my angle here, 36 degrees. And how did we find the apothem here? Okay, we're missing right here our apothem. Which trig function would we use? Tangent. Okay, so the tangent of 36 degrees equals the opposite, which is 2, over the adjacent, which is just our apothem, we aren't sure. And then we have that the apothem is equal to 2 over the tangent of 36 degrees. Okay. How did I get there? Right? Do we know that? We've seen this a couple times, right? So before I move on, I want to point out something. Okay, we can take note of it. You weren't expected to use this, but it is helpful for some. So for those of us who understand Anytime you want to find the apothem, actually always going to be equal to the opposite side divided by the tangent of whatever angle we have, okay? So if you want to use this and let it help you, you can, okay? But you can just do the same steps that we had. But I want you to notice in both of these examples, the apothem is actually equal to the side divided by the tan of the angle. Okay, and again, the apothem is equal to the missing side, or I'm sorry, the opposite side divided by the tan of 36. Okay, so if you want, I'll write that on the board when we finish here too. Okay. So how do we find the perimeter? Perimeter equals anybody? There we go. Okay, it's a mixture of it. So the perimeter is the number of sides, which is 5, times the length of the sides, which is 4. So my perimeter is going to be 20. Alright, step here is just area equals half times the perimeter times the apothem. Straight across, and the top here is 1 times 20 times 2, which is 30, divided by 2 times the tangent of 36. That's 40 divided by 2, 20. So it's the equals 20 36 degrees inches squared. Okay, this really is just like yesterday. It's just that whenever we don't get an angle of 30 here or 35 here, we cannot use our rules, okay? This is where we have to use trigonometry. So, sheet, I'm going to pass back. I want you to focus on 1, 2, and 4, okay? And if you want to take a shot at it, but please do these 3 first, okay? I want to make sure you have those 3 done first. Once you finish number 4, you can try the challenge problem, okay? And the reason that it's a challenge problem is because you have to use trigonometry more than once, okay? You have to use the SOHCAHTOA stuff more than once. So before you try number 3, make sure you have 1, 2, and 4 done, okay? Any questions?